In a previous tutorial, I introduced you to the idea of writing an equation of the form a sine x plus b cos x in the form r sine x plus alpha, or the form r cos x minus alpha. In this video, we will make use of the following two questions to practice that idea. Question 1 requires us to express sine x minus 4 cos x in the form r sine x minus alpha. The second question is 2 cos x minus sine x, and that has to be written in the form r cos x plus alpha. As always, I encourage you to pause the video and attempt the two questions on your own, and then play back the video when you have finished. Welcome back. I trust that you had some success in the two questions. Let's get straight to it. So the whole idea is to try and write this left hand side as what we are given on the right. So if I expand the two, well, the left hand side is given as 4 cos x, and it's going to be identical to the right hand side, and that expansion is r sine x cos alpha minus r sine alpha cos x. We found out in the previous tutorial that the value of r is found by taking the coefficients of the two terms, and in this case the coefficient of sine x is going to be equal to 1, so it's the positive square root of 1 squared plus 4 squared, and that should give us r to be equal to the square root of 17. Now if I equating coefficients of sine x, on the left hand side I've got 1, and that should be equal to the coefficient of sine x on the right hand side, which is the square root of 17 in place of r, and we also have cos alpha. So if I go ahead and solve for alpha, you'll find that alpha is equal to the inverse, cos inverse of 1 divided by the square root of 17. Now using your calculator, you'll find that alpha is equal to 75.96 degrees, corrected 2 decimal points. Alternatively, you could have used the coefficients of cos x. Now please take note that you don't need to do this. I'm just doing it to demonstrate that you will get the same value of alpha. So the coefficient on the left hand side is minus 4, is equal to the coefficient of cos alpha on the right hand side, and that is going to be equal to minus r, and that's sine alpha. But we already found that r is equal to the square root of 17, and if we divide both sides by the negative, you will have 4 is equal to the square root of 17 sine alpha, and therefore alpha is the sine inverse of 4 divided by the square root of 17. Now you will check on your calculator again that you find alpha to be equal to 75.96, again correct 2 decimal points. So to answer the question, what we are saying is that sine of x minus 4 cos x is equal to the square root of 17 sine of x minus 75.96 degrees. Now let's move on to question 2, doing a similar thing where we expand the right hand side and keeping the left hand side the same. We're going to have this being identical to r cos x cos alpha, but because it's a plus here, then this becomes minus r sine x cos alpha. Now again, the value of r is given by the square root of the square of the coefficients, and here it's going to be negative 1, so plus 1 squared, and this will give me 2 squared is 4 plus 1 squared, so that will be the square root of 5. Okay, now I'm going to take coefficients of cos x. On the left hand side, the coefficient of x is equal to 2, and on the right hand side it will be r cos alpha. But we already know that r is equal to the square root of 5, so we're saying 2 is equal to the square root of 5 cos alpha, and so our alpha is cos inverse of 2 over root 5. Thus alpha is going to be equal to 26.57 degrees, correct to 2 decimal points. So therefore 2 cos x minus sine x is going to be identical to the square root of 5 cos x plus 26.57 degrees. I trust that you had success in the 2 questions. Thank you for watching, and we will see you in the next tutorial. Cheers.